Okay, so this video will be discussing paper 3, okay, for pure mathematics 3, for May June 2024, paper 3-2. Okay, so let's start with question number 1. They want us to sketch the graph of this modulus x minus 2a, where a is a positive constant. Right, so when we want to sketch this particular diagram, right, if you want, you can try to substitute 2 points or maybe some points, okay, to get the shape of the graph. Then basically for this modulus graph, right, modulus linear graph, the basic shape is a V shape. So usually what I do is like I will want to find out the intersection, I will want to find the x-intercept first. So to find the x-intercept, I will let y equals to 0. Then I know that my x is equals to 2a. Okay, so this is my x-intercept, right? And after that, I will let x equals to 0. Then I try to get my value of y. Okay, so the value of y will be basically 0 minus 2a is negative 2a. Modulus negative 2a, you are getting 2a. Okay, and if you want, then basically you can substitute another value where it is greater than 2a for the x. So that you can see roughly where is the diagram. All right, or there's another option to sketch the diagram where you try to sketch the original graph without the modulus. That only reflect the negative part become positive, also can. So there are many different ways that you can try to sketch the diagram. You can use points to help you, or maybe you can draw the original graph first, that only reflect the negative part go up. So for me, I know that this is a reflected part, yeah, because originally I'm having negative 2a for this part. So when I put modulus sign, so modulus negative 2a means that you are reflecting originally negative value become positive. Okay, since I know this, therefore I want to find another point on the other side of x equals to 2a, on the other side of the x coordinate, x-intercept. So maybe for me, I will use, if let's say x equals to 3a. So what happened to my y here? So my y here will become positive 8. Okay, so once I get all the details for the point, then I can start sketching the graph. Okay, so first of all, I know that I have x-intercept 2a. So I assume that this is 2a lah, let's say. Then this is maybe the a and this is 3a. To make my graph look balanced, so I will try to use the scale for both the y and x-axis the same. Okay, so first point I have is x-intercept. So x-intercept is 2a, this one. Then y-intercept is 2a. After that, I got another point. When x equals to 3a, value of y equals to a. So maybe it's somewhere here. Okay, so I try to join the line together to get a V-shaped graph. So it should be something like this. This is something that I should get. Okay, you assume that this is a linear line, and then this one looks something like this. Okay, where you pass through these 3 points by using the straight line. And in general, the modulus graph is usually having the basic shape of V shape. Modulus linear graph, alright? So you can see that, oh, it is actually having a V shape, so should be no problem for the answer. Okay, then let's have a look for part B. For part B, they want us to solve this inequality. Then again, to solve this inequality, basically there are a lot of different methods that you can use also. For me, usually I try to find out the intersection point first for these two graphs. Okay, so to find the intersection point, I will let 2x minus 3a equals to the original value, original equation, and also I let 2x minus 3a equals to the negative of the original function. So the negative here means that I reflect it, the reflected function. Okay, then I try to simplify the equation to get the intersection point for these two graphs. Alright, so I'm having x equals to a if I solve this equation. And then for this part, I'm having 2x minus 3a equals to negative x plus 2a. Okay, so if I try to simplify my equation here, by right, I'm having 5a divided by 3. Alright, so these two are the intersection point of these two equations. Okay, and now I need to decide which part of the equation, right, or what is the value of x that fulfill this equation smaller than the modulus function here. Okay, then for me, what I'm going to do is that I will check the value part by part. So part by part means I'm having x equals to a, excuse me, x equals to 5a over 3. Okay, so I separate into 3 different parts here. Okay, so for the first part, this is where I have the first part. This part belongs to the area for x smaller than a. So for me, maybe I will use the value x equals to 0. So when you use x equals to 0, right, I substitute into my original inequality here. So I'm having 2, 0 minus 3a, okay, then smaller than modulus 0 minus 2a. Oh, not enough space. Wait, I write it better. So I'm having 2, 0 minus 3a smaller than modulus 0 minus 2a. Then I try to compare left and right hand side. So for the left hand side here, I'm having negative 3a smaller than modulus negative 2a. So modulus negative 2a means 2a lah. So negative 3a smaller than 2a, and both the a are positive value, right? So that means this inequality is a correct inequality. So I put a tick. Alright. Then after that, we have the second part here. This is the center part. So now I want to use x equals to any value like between a and also 5a over 3. So for me, I'm using 4a over 3 here. Same thing happened. I substitute 4a over 3 into the inequality on top, then try to compare them. Okay, so if I try to simplify the equation, yeah, I'm having negative 1 over 3a smaller than 2 over 3a. If you try to compare, okay, the inequality here, this is the the correct inequality, right? So I put a tick here as well. Then lastly, for the last part, I select any value that's more than 5a over 3. So maybe I'm using 2a here. Substitute into the inequality again. Okay, so if you substitute it and simplify, you will be having a smaller than 0. For here, you know that a is a positive value. So positive value smaller than 0, it is not a correct inequality lah. So you put a cross here. So after you check, you go through with the step and check, right? You realize that the part of the x with the correct inequality is this whole part here. Therefore, your answer for this inequality should be x smaller than 5a over 3. Because if you substitute any value that's having x greater than 5a over 3, your inequality is a wrong inequality. It's not correct. So we only consider the correct part. Right. Therefore, this is the correct answer for this, for solving this inequality shown in the question. Alright. Yeah, so this is how we solve question number 1. Okay, so now at question number 2, they want us to express this fraction into a partial fraction. Okay, so before we can start expressing this into the partial fraction, we have to check the degree of the numerator on top and also at the numerator, the degree of the numerator or degree of the denominator. For numerator, you can see that the degree is equals to 2, right? The highest power of x is equals to 2. For the denominator, is also the same. The highest power for the x is also 2. So the degree is equals to 2. And when you are having, okay, the degree on top is equals to or greater than the degree at the bottom, we call this as improper fractions. Okay, so this is improper fraction basically. And if we want to change the improper fractions, become the partial fractions, first of all, we need to figure out the first number first in front. Where to get the first number, we simplify it, we have to use long division first. Okay, so that's the first step that I want to try. So for the long division here, basically it's like this. The numerator on top is basically your polynomial, and the fraction, okay, the term or the expression at the denominator, it will be my divisor. So for long division, I'm using polynomial divided by the divisor. Okay, so now I have to think about a number. A number multiplied with 2x squared to get 6x squared. So the number should be a 3. So that 3 times 2, you get 6x squared. So at the same time, 3 also need to multiply with negative 5x. 3 also need to multiply with this one. So 3 multiplied with negative 5x, you have negative 15x. Then 3 multiplied with negative 12, you're having negative 36. Okay, then after that, you try to take the term, upper term minus the lower term here, negative 9 minus negative 15, and you should have a 6. Okay, then negative 16 minus negative 36, you're having 20. Alright, so this is what I call it as remainder. Okay, so this is quotient, this is polynomial, and this is divisor. How can I express all this into a correct or a proper equation here? Okay, so originally, when we want to write out the polynomial in terms of divisor, quotient, and remainder, right? The original formula is like this. Polynomial equals to divisor multiplied with quotient plus remainder. But in our question here, we're having polynomial divided by divisor, right? So that means for every single term here, I try to divide it by divisor. So and I'm having polynomial divided by divisor equals to quotient plus remainder over divisor. So this part is basically my question. Alright, so for me, if I want to rewrite my equation, my fraction into a proper equation here, so you can use this pattern where I'm having 6x squared minus 9x minus 16 divided by 2x squared minus 5x minus 12 is equals to quotients. What is the quotient that we get from long division here? It is a 3, so you can write out as a 3. Then plus remainder divided by divisor. So my remainder is 6x plus 20 divided by the divisor again, which is 2x squared minus 5x minus 12. Okay, so you can see that I have now changed the improper fraction become something like this, where this particular fraction here is a proper fraction. So for this proper fraction, you can start expressing them into a smaller partial fractions. Okay, all right. So we will focus from this part now. Excuse me. Okay, so for this part, I'm going to continue it by using the partial fraction to separate into the partial fraction. So 6 over 20 divided by, okay, so for the denominator here, I can try to factorize them into two smaller brackets, which is 2x plus 3 and also x minus 4. Both are linear factor, so I will separate it become a over 2x plus 3 and also b over x plus 4. Oh, sorry, x minus 4. Okay, so multiply the whole equation with the original denominator. So left hand side, your denominator disappear. Then for the right hand side here, 2x plus 3 and 2x plus 3 cancel off. You're having x minus 4. Same thing happened for the b here. X minus 4 and x minus 4 cancel. You have 2x plus 3. Okay, now you need to decide a certain value for the x so that you eliminate the unwanted unknown. So we look at this bracket first. If I let x equals to 4, this particular bracket will become 0, right? Okay, so this particular bracket will become 0. So 6 times 4, you get 24. 24 plus 20, you will have 44. Then equals to right hand side. 4 minus 4, you get a 0. So 2 times 4, you get a 8. Plus 3, you get 11. So 11b. Excuse me. Therefore, from here, you can get your value of b, which is equals to 4. Then we repeat the same process again. So now by looking at this particular bracket here, Okay, so I highlight with purple color. So for this purple color bracket, if I want to make it become 0, I need to let x equals to -3/2. Substitute x equals to -3/2 into the equation here. Alright, so by right I'm having 11. That equals to -11/2a. So simplify your equation again, your a will be -2. So that now you can see that original improper fraction, I separate it becomes something like this, where this part is the proper fraction. So for this proper fraction, I further expand it become the partial fraction. Therefore, now I can rewrite my final answer again completely. Okay, so where my original question is, I will have this one, 6x squared minus 9x minus 16. Okay, then divided by 2x squared minus 5x minus 12 can be written as 3. So 3, then plus this particular fraction can be expressed as these two partial fractions. So what is the a here? A is -2. So you maybe need to put a -2. -2 over 2x plus 3. B is a 4, then plus 4 divided by x minus 4. Okay, yeah, so this is how we basically express the improper fraction into partial fractions. So in my solution here, the long division is needed because you have to change the improper fraction become something like a proper fraction first before you can expand it into partial fraction. Alright, so this is how we solve question number 2. Okay, so question number 3. The variable x and y satisfy this equation where a and b are constant. They want us to show that the graph of y against x is a straight line. Okay, when we are having the equation with power and especially the power is not a 1. Okay, so basically it is a curved one. So how can we show that it is a straight line? So we need to actually think to rephrase our equation into the term of y equals to mx plus c. To do so from a equation with power, basically you have to take ln both sides or log both sides. When you take ln or log both sides, you can pull the power in front. Okay, that means you have no more power, and then you can try to rephrase and see whether you're able to express your equation into the pattern of y equals to ms plus c or not. Because you know that y equals to ms plus c, right? It is a linear equation, a linear line, right? And then usually for the y here will be your the variable that you draw in the y-axis, and then the x here will be the variable that you draw in the x-axis. Okay, so let's have a try first. So this is my original equation. Okay, take ln both sides or log both sides also can. When you take log or ln both sides, you can pull the power in front become the constant. So 2y minus 1 ln a equals to x minus y ln b. Okay, then next one. Now we try to group and have a look whether is it possible for me to group all the y on the left or the x on the right. So I want to group all the y one side, all the x one side. So what am I going to do now here is, for this part, I maybe can expand the y first. So I'm having 2y ln a minus ln a. Then x ln b minus y ln b. So you can see from here that it is possible for me to separate the x and y to two different sides. Okay, so if I try to group all the y on the left, I bring the y ln b over here, then all the terms without the y on the left. The constant term also I can put it on the right, sorry. X and also the constant term should be on the right, yeah? So this is something with the x, this is something like a constant term. So I put everything on the right. These two terms are having the y, so therefore I put it on the left. Okay, then after that, I can factorize out the y. Then this is what I have for now. Okay, move the bracket over. So I'm having ln b divided by 2 ln a plus ln b. Then I should have an x here, right? And then I'm having ln a also divided by the same denominator, 2 ln a plus ln b. And now if I try to compare my equation with the linear equation, the general term for linear equation, my y-axis is the y, which is correct. My x-axis is the x, which is correct. Because here they did mention that y against x. That means your y-axis should be the y. Your x-axis should be the x. So y-axis is the y, x-axis is the x. So that means your m is equals to this one. C is equals to this one. Okay, then you can make a simple conclusion. Alright, so you can say something like the equation is matched with linear equation y equals to mx plus c. Okay, if you want to tell them further, you can tell them that where the m is equals to this value, okay, and then the c is equals to this one. Okay, so hence the graph y against the x for this equation is a straight line. Just try to make a simple statement where you are trying to compare your answer with y equals to mx plus c, and you can see they are matching. Alright, so therefore this particular equation is actually a linear equation, or it's a straight line. Alright, okay, then let's continue to next part, part B. Now they give us another extra information. A equals to b power 3. They want us to put our equation in y equals to px plus q. Okay, so that means this equation that we try to express just now, right? They want us to put it in the form of p x plus q. That means p and q are rational number. Okay, so they don't want to have the equation looks like so complicated, the m so complicated. Okay, because you're having ln b divided by ln a some more, right? So you have to make this whole thing become a number, a rational number. This part also become a rational number. Therefore, I have to substitute a equals to b power 3 into my equation here. Okay, so let's substitute into the m first. Okay, so ln b, it is just ln b. Then divided by 2 ln a. So what is 2 ln a here? Okay, I'm having 2 ln a. A I substitute by using b power 3. Then plus ln b. Okay. For the 3 here is a power, I can put it in front. For the 3 here, I can put it in front, multiply with the 2. Therefore, I'm having ln b divided by 6 ln b plus 1 ln b. 6 plus 1 equals to 7, right? So if you have a look here, you'll be having ln b divided by 7 ln b. Ln b and ln b can be cancelled off. So your gradient m is equals to 1 over 7. Right? Okay, then how about for the c? So same thing happened. Originally, I'm having c equals to ln a divided by 2 ln a plus ln b. Okay, I will want to substitute a equals to b power 3 into my equation. So I will be having ln b3 divided by 2 ln b power 3 plus ln b. Again, the 3 here, I can put in front. 3 times 2. The 3 here, I can also put in front. So if I rephrase it, I'm having 3 ln b divided by 6 ln b plus ln b. So the denominator, right, it is like 6 apple plus 1 apple. So you're having 7 apples. So 3 ln b on top divided by 7 ln b at the bottom. Again, ln b and ln b can be cancelled off, and therefore your c is actually 3 over 7. So you know that m is a gradient, c is the y-intercept, right? So when I want to rewrite my equation in the form of y equals to mx plus c, it will be y equals to 1 over 7x plus 3 over 7. And this is particularly what they want us to show here, like px plus q. They just let the gradient equals to p, then the y-intercept equals to q. So p is 1 over 7 for our case here, and then the q is actually 3 over 7. Okay, yeah, so this is how we solve question number 3. Okay, so question number 4. We are given the equation of a curve like this, and then they want us to find the value of gradient of the curve. Okay, so what's the meaning for gradient of the curve here? So you should know that gradient of the curve means dy dx. Okay, so what is the value of dy dx when y equals to 1? Right, so from equation given, right, if you want to find the dy dx, basically you need to apply differentiation, right? Okay, so for this particular equation in this part, you can have a look that I can't clearly separate x and y to two different sides. That means I'm having, no matter how you try, you can have a try. Okay, so no matter how you try, you found that it is not easy for you to separate y on the left and then all the x on the right. Therefore, to find the dy dx, you have to apply implicit differentiation. Okay, all right, and besides the implicit differentiation, you can have a look that you are having two terms here that includes both y and x in a term. So basically, you can treat the y as a u and then e power dx as a v. So same thing happened here. This is u and this is v. So if you want to differentiate the product of two different functions uv, so basically the common formula is you differentiate the first term first, which is du over dx. The second term you copy. So v du dx, then plus, now you do it the other way around, where you copy the first term, then you you differentiate the second term, second bracket. Okay, so in short, this is something like this. Differentiate the first bracket, copy the second, then copy the first bracket, differentiate the second. So this is the product rule. So you have to apply product rule twice in this whole equation here. Okay, so let's start. Right, so I'm having y, and then e power 2x plus y square e power x equals to 6. Okay, so for the first uv here, this is the first uv that I have. Okay, so for the first uv here, I copy the y first, copy the first bracket, differentiate the second. So differentiate e power 2x, I will have the original thing e power 2x. Differentiate the power, you get a 2. So this one is copy the first bracket, differentiate the second. Then now I want to differentiate the first, copy the second. Differentiate the first means differentiate the y. Differentiate the y, I get a 1. But because this is y, right, so I need to put in dy over dx. Okay, just now when you want to differentiate e power 2x, by right you should have dx over dx one. Just that we didn't write out usually because dx over dx is a 1. Okay, but for dy over dx cannot be simplified. So after you differentiate the y, you have to put the dy dx at the back. Okay, then copy the second bracket, which is e power 2x. So here I done the very first product rule, product differentiation. Then I continue to apply it for the second product differentiation using product rule. Okay, so again, copy the first bracket, which is y power 2. Differentiate the second bracket, which is e power x. So if you differentiate e power x, you still get the same thing, e power x. Then now, you do the other way now. You copy the first bracket, sorry. You differentiate the first bracket. Differentiate y squared, you get 2y. Then you put the dy dx. After that, you copy the second bracket. Okay, so you can see that this part is the differentiation using product rule for the first time. Then this one is the differentiation by using the product rule for the second term here. Okay, then after that, differentiate the 6. So 6 is a constant. Differentiate the 6, you get a 0. Alright, okay, then after that, to get the value for dy dx, of course, you need to group all the dy dx together. So I'm trying to group all the dy dx together. For this term, I will take out the dy dx, factorize out the dy dx, I'm having e power 2x. For this term, if I take out the dy dx, then I'm having 2e power xy. Then equals to all the terms without the dy dx, I will move it to the right hand side. Okay, next step. For this one, I realized that I can still factorize out something else, which is e power x. For the left hand side also, I realized that I can factorize out negative y, then e power x also. Okay, then because my final answer, right, my final aim is to get the value for dy dx, so I bring all the things over to the other side. Okay, so this is basically the dy dx that I get. I think you can still further simplify something else, right? So e power x and e power x can be simplified. Okay, so again, rephrase my final answer one more time. Okay, so this is what I have for my dy dx. Excuse me. Then, because I want to get the value for the dy dx, excuse me, so before I can get the dy dx, I need to know what's my value of y first. So you already know that y equals to 1. So y no problem. But the problem is I need to know the value of x as well. Excuse me. So to get the value of x, right, I need to get the value of x from the original equation. Excuse me. Okay. Alright, so if I try to substitute y equals to 1 into my original equation, basically this is what I get. And if you try to observe this, right, this is basically a quadratic form equation in terms of e power x. And you can factorize it nicely. Where you're having e power x and e power x here, then this would be a 3 and this would be a 2. Then you're having a plus 3 minus 2. Okay, so solve these two equations here. E power x equals to negative 3. You won't get any solution for this part because the graph for e power x is always positive. Alright? Then for e power x equals to 2, yeah, I think you no need to purposely go and solve for the value of x because if you have a look for the dy dx here, you need the value of e power x. So you can directly substitute 2 into your equation later. Right? Okay, so now I successfully get the value of x and also the y when y equals to 1. So further substitute my value here, my answer here into the dy dx equation. So I'm having negative 1. Negative y means negative 1. 1 plus 2 e power x is the 2 that we get here. Then 2 plus 2 multiply with the 1. Okay, so if I try to simplify from here, right, by right you should be having the value negative 5 over 4. Okay, so this is basically how we solve the question number 4. Let's discuss question number 5. We are given an equation here that has only one root. They want us to verify or show the calculation by calculation that the root lies between these two values, 0.7 and also 0.8. Okay, so for this kind of question, basically we need to make our equation become one function first. So let's make it in this way. So fx equals to 5 plus cos 3x, then minus e power 2x. Okay, so of course, if you want to do it the other way around also can, where you move the 5 and cos 3x to the other side, become minus 5 minus cos 3x plus e power 2x. Okay, then after that, we need to substitute the value in to the function. So we are having 0 0.7 and 0 0.8, right? So we have to substitute two value into the function f here. Okay, so of course, you can use calculator to help you. Right, so by right, if you substitute the value of 0 0.7 into this equation or this expression, you will get a value 0 0.440. And if you substitute 0 0.8, then you will be having negative 0 0.690. Okay, so if let's say you're not able to get the answer as what I shown here, please make sure that you double check your calculator whether is it in radian mode or not. Okay, so the reason is because in our calculation for this part, we are having something involved trigo, which is cos 3x. So for cos 3x, all the value that we substitute here should be in radian. Therefore, our calculator should be in radian mode as well. Right? Okay, then after you substitute these two values, by right, you should have seen one positive value and one negative value. So we call this as sign change. So if the sign change can be seen between these two answers, then basically it means that your root lies between the 0 0.7 and also 0 0.8. Right, so I think we can see very clearly, right? Our answer here, we are having one positive and one negative value. So we can make a simple statement to conclude it. So you can write it in this way, sign change can be seen. Alright, so between these two values, okay, so therefore the root is between 0 0.7 and 0 0.8. Right, so basically this is how we prove it. So make sure you put your calculator in the radian mode to get the correct value. Alright, okay, so let's continue to the part B. For part B, they want us to show that if a sequence of value in this interval given by the iterative formula, and this iterative formula actually converge to the roots of the equation in part A. So when you see this kind of question, right, the meaning of it basically is you can try to rephrase your original equation, become the iteration formula, or the other way around. You can also start from iteration formula, then go back to the original equation. Okay, so they just want you to prove it because they just want you to show that if let's say I'm using this iterative formula, right, I can get the answer, and that answer is basically the answer for this equation. That's the meaning. All right, okay, so let's start. Usually for me, I will start from original equation. Okay, so you can do it the other way around, no problem at all, right? So I'm having e power 2x equals to 5 plus cos 3x. Okay, so I can see from here, basically I want to take ln later. So if I take ln, I have to take ln both sides, correct? Therefore, my right hand side, I'm having ln 5 plus cos 3x. So I think the answer is quite obvious really. Okay, so I pull the 2x in front, the power of 2x in front, so it becomes 2x ln e equals to ln 5 plus cos 3x. Then by right, you should know a small concept here where ln is log base e, right? So ln e should be equals to 1. So you have only 2x on the left. Therefore, if I move the 2 over, then I'm having 1 over 2 ln, then 5 plus cos 3x. Right, so basically this is how we prove. Okay, so I'm proving from original equation to the iterative formula. You can also do it the other way around, where you start from iterative formula, go back to the original equation. Okay, right, so let's continue to part number C. For part number C, they want you to use the iterative formula to determine the root correct to 3 decimal places. And then each iteration should be up to 5 decimal places. Okay, so for iterative formula, right, to get the answer, first of all, I need to key in the iterative formula in my calculator. Alright, so let's have a look for the iteration formula here. So you are having half ln 5 plus cos 3x. Okay, so first thing, I want to double check to make sure that my calculator is in radian mode. So you can see this is R, right? Okay, then we can key in the formula, the iterative formula on the right hand side. So right hand side I'm having a fraction, then I'm having ln, then 5 plus cos 3x. So I'm trying to key in the formula here. Okay, so ln 5 plus cos 3x, then divided by 2. So divided by 2 means this one. Okay, so this is my iterative formula provided in part number B. So I want to use it in my part C. Okay, so for the part C here, I need to have the initial value. For this question, they didn't give me any initial value to start with. So you can start with any value that you like. But of course, I usually will try to tell students, if can, try to use the value that's close to 0 0.7 or 0 0.8 because we know that the root is not too far away from these two values, right? So you can use any value that's close to this one. For me, in this example, I will use 0 0.75 to start with. Okay, so how can I get, if let's say I determine this one to be my initial value, right? So to get the second x, you need to substitute your initial value into the iterative formula. That means you have to substitute 0 0.75 into this particular formula here. Okay, so to get the answer for x2. But of course, we can use calculator to help us. Alright, so how can I use the calculator to help us? So first of course, like what I said just now, you have to key in the formula first. Then after that, you try to press on the calculate sign. And then they're asking you, what's the first value of x that you want to put in? So we are putting in 0 0.75. Okay, so type in 0 0.75, then you press the equal sign. Okay, so this is the answer that you get for x2. And if you read the question again, they want you to give the result of the iterative formula correct to 5 decimal places. So that means when you want to write the answer for this part, please keep it for 5 decimal places. If you have a look for the answer here, it will be 73759. So you write out 0 0.73759. This is the iterative correct to 5 decimal places. Okay, then continue further, you have to repeat the same process. Okay, so I want to get the x3. So to get the x3, I repeat the same process where I press the calculate again. They ask you again, what is the value for x? So now we key in the value for x2, 0 0.73759. Then you press equal sign. Okay, then again, the value for x3 is shown here. So you just put in the 5 decimal places answer, 0 0.74094. So 0 0.74094. Okay, so let's continue to x4. Alright, so until which stage we need to stop or we can stop. Okay, so basically, if I have repeated value for 3 decimal places in my iteration, then we can stop. So as an example, for this one, I'm getting 0 0.738 correct to 3 decimal places. Then for this one, I'm having 0 0.741. I think very obvious, right? Because these two values, you can see clearly that they are not the same. Therefore, you have to continue further to get the correct value of the repeated value for 3 decimal place. Okay, so again, to get the value for x4, you press calculate again, key in the value for x3. So I'm having 0 0.74094. Then you press equal sign again. So now these the 5 decimal places answer here will be 0 0.74003. Okay, then again, this one, I'm having 0 0.740, not repeated yet. So let's continue further for x5. Okay, so my calculator off already, so let's open it again. Alright, then how about the next value? So I key in the formula one more time, yeah? So I'm having ln, then 5 plus cos 3x, then divided by 2. Okay, then now I press calculate again. Then key in the value 74003. So 74003. Then press equal sign one more time. So I get this 74028. So 0.74028. Then again double check. So you realize that this is actually a repeated value for 3 decimal places. So both of them are 0.740. Therefore, we can stop here lah, because we already get our root. Alright, so you can rewrite again your root in the final answer, which is 3 decimal places. So you will write it out as 0.740. Alright, so this is basically how we use the calculator to get the iterative value using the iterative formula provided in the question. Right? So this is how we solve question number 5. Okay, so question number 6. We are given a diagram with this equation of the curve. A is a positive constant, so want to find the maximum point M, exact coordinate for M. So M is the maximum point, right? Therefore, you have to apply differentiation. When you see this one, maximum point, to get the coordinate, you have to let dy dx equals to 0. Okay, so we will start with our equation here. So y equals to x e power negative ax. So it is a product of two functions. X is the first bracket, e power negative ax is the second bracket. Therefore, if I want to differentiate this equation, I have to use product rule. Alright, so use the product rule. Means that you can differentiate the first bracket first, copy the second, then plus copy the first bracket, differentiate the second. Okay, so this is the shortcut I use usually. Alright, okay, so maybe my first bracket here is the x, then the second bracket will be e power negative ax. Alright, so I want to find the dy dx here. Okay, so to find the dy dx, x is the first bracket, so I copy the first bracket first, differentiate the second. So differentiate e power negative ax, I get back e power negative ax. Then I differentiate the power, I get negative a. So I have to multiply the negative a after this. So just now I copy the first, differentiate the second, right? So now I do it the other way around, where I copy the second, which is e power negative ax, then differentiate the first bracket. Differentiate the first bracket is the x. So differentiate x, you get a 1. Okay, so you successfully get the dy dx already. So second step, you let dy dx equals to 0. And we are going to learn to solve this equation. Okay, so from the answer that I get for dy dx, I can factorize out e power negative ax. Then I'm having 1 minus ax here. Okay, so 1 minus ax, it is equals to 0. Therefore, your x is equals to 1 over a. Then another part I want to solve, e power negative ax equals to 0. And you realize that there's no solution from this part, because if you try to solve it, you take ln both sides, you'll get a mass error. Therefore, there's no solution here. So maybe we can write no solution. Okay, then after I get the value for x equals to 1 over a, they want us to have exact coordinates of M. So I have to substitute x value into the y equation to get the coordinate of y. So let's substitute it. So I'm having y equals to 1 over a, then e power negative a multiplied with 1 over a. So what do we have here is 1 over a, e power negative 1. So if you want to further rephrase it, then you're having a e1, 1 over a e power 1. Okay, so this is basically the answer. Therefore, I rewrite again where it is the coordinate maximum point of M. So it will be 1 over a here. And after that, this is 1 over a e power 1. Right, so basically this is how we get the answer for the coordinate of the maximum point. Alright, so let's continue to part B. Okay, so for part B, they want us to find the exact value of this integration. Highlight the keyword exact value. Okay, so that means your final answer cannot be in decimal number, yeah? It must be in surd form, pi form, okay, or fraction. Then now, how can we integrate this expression here? Xe power negative ax. So again, it is the product of two different functions. So when we want to find out the integration for the product of two different functions, we basically need to apply integration by part. Okay, so the integration by part formula is provided in the formula booklet. So this is what we have. But usually to make it easier, right, what I do is like I actually not looking at the dx, so I actually cancel off the dx one, because dx and dx can be cancelled off here. This one also the same. So usually for the formula that I use here will be integrate u dv equals to uv minus the integration of v du. Okay, so this is the formula that I usually use. Okay, so let us go back to our solution first. Okay, so there are a few things that we need to go through before we can start the integration. So first, I know that I'm using this formula. Integrate u dv equals to uv minus v du. Okay, so basically this part is the question. This is the question. Okay, all right, so we need to decide which part of my question become the u and which part of my question become integration of dv. So we have a rules to decide, so which is LIATE, Liat rule. So the L will be logarithmic function, I will be the inverse trigo, okay, then what is the A? A will be algebra, T is trigo, then E is exponential. Okay, all right, so the higher group will be the U and the lower group will be integration of dv. Okay, so let's analyze our question here now. X is algebra. Then e power negative ax is exponential. So the higher group will be the u, right? So what am I going to do now is I will let u equals to x. Then the remaining part will be the integration of dv. So the remaining part that we have here is integrate e negative 2x dx. Oh, sorry, negative ax dx. Okay, so this is how we decide which part will be the u and which part will be the integration of dv in the integration by part. Okay, then how to continue next? All right, so let's continue with the u and x first. So I want to differentiate this part. Du over dx equals to 1. Therefore, your du is equals to dx. And then for the integration part here, there's a 1 here. So integrate 1, you get a b. Integrate e negative ax, you copy back the original thing. Then divide by differentiation of the power. So you have negative a here. So this is my v. Okay, so once I settle everything here for the u and also integration of dv, then I can start applying this formula. Okay, so I bring it down here. Easier reference for you to refer it easier. Okay, so let's start now. My original question is this one. I'm having the integration of 2 over a, 0, then x e negative ax dx. Okay, so before we start the integration, we need to know that our final answer must be in exact value. So later when you try to simplify everything here, we try to simplify it in a fraction form or maybe the e form or pi form, okay? All right, so this is my question. This is my question, so it is this one. Then it is equals to what? uv. So what's my u here? U is the x. What's the v? V is this thing. So you just multiply them together. So this is UV lah, because my integration here got limit lah. Therefore, I have to substitute in the limit later into this phrase. Okay, so this is UV lah. Then minus, the integration sign is not here. Okay, so minus, you just copy the minus, integrate again. So you just put integration. Of course, the limit is still there. Then V. So again, what's your V? Your V is this one. So E power negative AX divided by negative A. Then what's the du again? So du, if you have a look for my step just now, it will be equals to dx. Okay, so this is what I have lah, after I've substitute everything into the integration by part formula. Alright, so for me, my personal habit is I prefer to take out all the constant before I want to substitute the value inside the expression. So you can see here, I try to take out the negative 1 over a first, so that my steps later looks not so complicated lah, I would say. Okay, then for this part also, you try to take out the constant a, so that it's easier for you to integrate. Alright, so next step. Now we try to substitute in the value of 2 over a inside the first term here. So I'm having 2 over a e power negative 2. Because a and a can be simplified, so you are having a 2 here, so it becomes power negative 2. Then minus, now you want to substitute 0 into this phrase or this term, you will get a 0. Okay, then plus, copy the constant term. Now I want to integrate e power negative ax. So copy back the original thing, then divided by the differentiation of the power, so I get negative a. Again, I will want to substitute in the value 2 over a and also 0. Okay, so I think so far all the steps here are quite not too complicated, right? Although we have fractions. Okay, then now for the first term here, we can try to simplify first. I'm having negative 2 over a square, then e square. Okay, then minus. For the negative a here, I will bring it out, become negative 1 over a square as well. Then now substitute 2 over a into the e power negative ax. So I'm having e power negative 2. Then minus, substitute 0 into this term here. E power 0, you get a 1. Okay, so maybe you need to take note on this part, because there are a lot of students, right? They thought that every time when we substitute anything 0 into the expression, I will get a 0. But it is not, yeah? So this is a common mistake that usually students will do, okay, when they try to simplify the answer. So it is a 1, not a 0, because e power 0 should be a 1. Okay, then of course you can continue to simplify your answer now. Okay, so I'm having negative 1 over a square e square, then plus 1 over a square. Okay, then from here, I think we can see also quite clear. I can factorize out the 1 over a square here. Then I left 1, then minus 2 over e square, minus 1 over e square. So negative 2 over e square and negative 1 over e square, it is like you minus 2 apple, then minus 1 apple again. So end up to simplify them, you should have 1 minus 3 over e square. Okay, so I will keep my answer in this form because they are asking for exact value or exact answer. Alright, so this is how we solve question number 6. Okay, so question number 7. So they want to show that this equals this one. Alright, so let's start. For me, I will start from left hand side here. Cos power 4 minus sine power 4. How can we simplify cos power 4 minus sine power 4? Okay, basically I want to use this one. I want to use the formula where x squared minus y squared can be written as x minus y and then x plus y. So same thing happen if let's say I'm having x power 4 minus y power 4. Then if I want to separate them, I will be having x squared minus y squared, then x squared plus y squared. Okay, so basically I'm using this. Yeah, so your cos is like your x, then the y will be the sine. Okay, so let's have a look for the left hand side first. So cos power 4 minus sine power 4. Okay, so I will be having x squared, which is cos squared, minus y squared, which is sine squared, then x squared, cos squared, plus y squared, sine squared. Okay, so I think from here it is quite obvious that you should know, yeah? You know that we are having the identity where cos square plus sine square equals to 1. Okay, so your next step will be you are having cos square theta minus sine square theta times 1. Okay, so how can I equate cos square theta minus sine square theta equals to our answer here? So basically we are having a double angle formula where cos 2 theta is actually equals to cos square theta minus sine square theta. So you can directly change it back, become the double angle formula for cos. Right, so this is how we get the part A answer. Okay, so let's continue to part B. Okay, so for part B, they said hence find the exact value. Highlight the keyword exact value again. So they want to find out the integration for this one and must be in exact value. They use hence. So basically, you need to consider the answer that we get just now, okay, before we can integrate this one. So that means you have to substitute maybe the result just now somewhere here lah. Okay, then only you can continue with the integration. So let's start. Okay, so I'm having pi over 8, then negative pi over 8 here. Cos power 4. Okay, so since they asked us to use the result, because hence, right? So use the result in part A. Therefore, I think it's quite straightforward. You can change cos power 4 minus sine power 4 become cos 2 theta. This is the result that we get just now. Okay, then for this part, 4 sine square cos square, basically I want to make it become 2 sine theta cos theta, and then I square it. So that means I pull the square outside. Okay, so 2 square is a 4. Sine square is sine square, then cos square is cos square. Okay, so what I want to do next step is I want to use the double angle for sine 2 theta. Okay, so for sine 2 theta, I will have 2 sine theta cos theta. And now I have to do it the other way around. Okay, so I have to do it backward. Okay, so before I integrate, this is what I get. I'm having sine 2 theta and then square. Okay, so let's have a look for this step now. Can we directly integrate now? Okay, so for this first term, right, no problem for us to integrate because integrate cos power 1, I will get something like sine power 1. So no problem for us to integrate this part. But when we are having a trigo with a square, we cannot directly integrate in this way. Therefore, I have to try to think a way to change this sine square become nothing with square. Okay? Then by right, you should know that when I want to make something with square, because something without a square, you can always think about the double angle formula for cos. Okay, so let's say I use the original one first. For cos 2 theta, there's one identity. It is equals to 1 minus 2 sine square theta. Okay, so this is the original equation. But now, if you have a look for my question here, I'm having sine square 2 theta. In the formula here is sine square theta. So basically, we can modify the angle. So instead of theta, I make it become 2 theta. And then for the double angle formula here, cos 2 theta originally will become cos 4 theta. So you can see that I try to modify the angle so that it suits my question here, sine 2 theta square. And after that, I rephrase this equation. Therefore, if I rephrase this equation, right, so I will be using this sine square 2 theta equals to 1 minus cos 4 theta divided by 2. Okay, so if I let this one equals to this particular term here, you can see that there's no more square in your trigo. Okay, all right, so this is what I want to apply for now. Okay, so I'm having 1 over 2, then minus cos 4 theta over 2. I want to separate it out because it's easier for me to integrate later. Okay, all right, so now since everything here has no more square with the trigo, right? So you can start the integration now slowly. Okay, so just to recall back, yeah, if in case you forget, all right, so I'm using the concept of this, or maybe the formula. If I want to integrate cos mx, so differentiate sine to get a cos, therefore integrate cos, you will get a sine. So I'm having sine mx, then you differentiate the thing inside the angle, you get an m, right? So you have to divide it by the m. So same thing happened here. Okay, so I'm having cos 2 theta. All right, so when you integrate cos, you will get a sine. So you have sine 2 theta divided by, differentiate 2 theta, you get a 2, right? So you divide it by 2. Half is a constant, so when you integrate, you will get directly half theta. Okay, then I take out the 1 over 2 first. Integrate cos 4 theta, you get sine 4 theta. Differentiate the 4 theta, you get a 4, right? So you have to divide by a 4. Okay, so again, every time before I substitute the limit, I prefer to take the constant beside, or maybe take it out first if can. Okay, so like for this particular part here, I can take out the half. So I'm having sine 2 theta plus theta, then minus 1 over 4 sine 4 theta. And I want to substitute in the limit pi over 8 and also negative pi over 8. Okay, so let's start with pi over 8 first. Substitute pi over 8 into 2 theta, you have pi over 4. So sine pi over 4, you get square root 2 over 2. Okay, so for those who are using MS calculator, you need to draw the triangle to help a little bit. Okay, where you have pi over 4, then the value, the ratio for the triangle is 1, 1 and square root 2. So this is something that you need to refer to if let's say you're using MS calculator. Because MS calculator, they can't really help you to rephrase your answer in exact form, right? In this form, okay, or maybe in the third form. So you have to use the triangle a little bit to help you to get the value. Okay, so substitute pi over 8 into the first term here, you get sub 2 over 2. Theta means pi over 8. Okay, then pi over 8 times 4, you get pi over 2. So sine pi over 2, you get a value of 1. Okay, then now I have to substitute in the value of negative pi over 8. So sine negative pi over 4. So sine negative pi over 4 means it is in the fourth quadrant. Therefore, the answer for this one should be negative sub 2 over 2. Okay. Then again, substitute negative pi over 8 into the value here. You have negative pi over 8 here. Then minus 1 over 4, you just copy first. Substitute negative pi over 8 into 4 theta. So you're having sine negative pi over 2. So what's the value for sine negative pi over 2? Of course, you can always use calculator to help you. So you can see that sine negative pi over 2 is actually the value of negative 1. Okay, so I successfully substitute all the value inside. So now I try to simplify everything very carefully. I'm having cert 2 over 2, then pi over 8 minus 1 over 4 plus cert 2 over 2 again plus pi over 8. Okay, then minus minus is a plus. Plus minus is minus again. 1 over 4. Okay, so for all the terms here, cert 2 over 2 means half cert 2 plus another half cert 2. So you are having cert 2. 1 over 8 pi plus 1 over 8 pi, you get 2 over 8 pi, right? So you're having 1 over 4 pi. Negative 1 over 4 minus 1 over 4, you get negative 2 over 4, which is negative half. Okay, so if you want, you can keep your answer like this, or you can multiply in the half into every single term here. So if you multiply half into every single term here, you'll be having square root 2 over 2, then pi over 8, and also negative 1 over 4. So you can see that our final answer here is in the term, is in terms of cert 2 and also pi and also fraction. Okay, so this is how we solve question number 7. Okay, so we are now at question number 8. Right, so we are given point A, B, and C with the position vector. Then line L pass through B and C. So find the vector equation for line L. Okay, so if I'm having the line L like this, okay, so this is line L, and then it passes through the point B and point C. So to form the vector equation, we need two important parts. We need the passing point, and we need direction. So passing point, I can use the position vector for B or position vector of C lah. No problem at all. We have more than enough. Okay, then for the direction of the line, basically the direction of the line is like either you take BC or CB also can. So the vector BC or vector CB will be the direction of the line. Okay, so let's start from the direction first. Okay, so to find the direction of the line, I will, maybe for this case, I'm using BC lah. Okay, so BC means BO plus OC. So if I'm looking for BO, I'm having negative 5, and then negative 2, and then 0, 0K. Okay, 5i, negative 5i, negative 2j, then 0K. That's BO lah, right? Then plus OC. So for OC, I'm having 8, 5, negative 3. Okay, so if you simplify it, you'll be having 3, 3, and negative 3. For direction, we are allowed to factorize it into the most simplified form. So basically, I can take out the 3, then I will have 1, 1, and negative 1. So that means later, when I want to substitute my direction into the vector equation, right, this is the direction I can use. Instead of 3, 3, and negative 3, I can just use the most simplified version, which is 1, 1, and negative 1. Okay, right, so just to recall back, yeah, what is the general formula for vector equation? So I'm having R equals to A plus dB, where the A here will be the passing point of the line, and then the P here will be the direction of the line. So like what I showed you just now here, I already get the P. Okay, so sorry, I already get the P. Then I can directly put in all the details into my vector equation. Okay, so vector equation is R equals to A plus dB. So A, I want to substitute the passing point. B and C is the two passing point of the line. So you can use OB or you can use OC lah. So for me here, I'm using OB here. So I'm having 520, then plus T, and then the P. P is the direction, which is 1, 1, and negative 1. Okay, so this is the vector equation for the line 1. But of course, if you want to use OC, 8, 5, negative 3, and put it as the passing point at here, also no problem. So both answers are correct. Alright, okay, so let's have a look for part B. For part B, they give us another equation which is for line number 2. Alright, find the coordinate of the point of intersection of line L1 and L2. Okay, so to find the point of intersection, just like previously when we learned coordinate geometry, if you want to find the intersection point for two line or two curve, we need to equate equation number 1 to equation number 2. So same thing happen here. Alright, so I will let vector equation number 1. So my vector equation number 1 just now from part A is 5 plus t. I expand everything like 5 plus t, then 2 plus t, and 0 minus t. Equals to the line number 2, vector equation for line number 2. So for this vector equation, I'm having negative 2i with this one. So negative 2 plus 3 mu, 1 plus mu, and also 4 minus 2 mu. Okay, so from here, you can see that I'm having 3 sets of different value. Okay, so I'm having 3 sets of different value here, where, 3 sets of different equation, not 3 sets of different value, 3 sets of equation. So the first one is 5 plus t equals to negative 2 plus 3 mu. The second one is 2 plus t equals to 1 plus mu, and so on. Okay, so for me, I'm using the third one first to form the first equation. So I'm having negative t equals to 4 minus 2, 6. Oh, sorry, 2 mu. And then t is equals to 2 mu minus 4. And this is my first equation. Then after that, I want to use maybe the other one as second equation. So maybe this one is the second equation. Okay. So if I write out, I'm having 2 plus t equals to 1 plus mu. Excuse me. So t equals to mu minus 1. And this is my second equation. Alright, so I will solve this equation simultaneously. So 1 equals to 2. Okay, so 2 mu minus 4 equals to mu minus 1. Alright, so I successfully get the value of mu. Okay, so to find out the coordinate for the point of intersection, I just need to substitute the value of mu, go back into our equation number 2. Then the answer that you get is basically the position vector for the intersection point. Alright, then because they're asking for point of intersection and the coordinate, if they're asking for coordinate, then I will put it in the coordinate form, geometric coordinate form. Okay, so negative 2 plus 3 mu. That means negative 2 plus 3 times 3. That's my x coordinate for the intersection point. Then 1 plus mu is 1 plus 3, which is the y coordinate. Then 4 minus 2 mu will be 4 minus 2 times 3. Okay, so from that, you can simplify your answer and get the coordinates of the intersection point, which is 7, 4, and also negative 2. So this is how we solve part number B. Okay, so let's continue to part C. Okay, so for part C, they are saying that the point D on line L, L2 is such that AB equals to BD. So find the position vector of D. Alright, so I'm having line 2. Okay, so when the D is on line number 2, right, basically the position vector of this point will be equals to the vector equation of the line. So from part B, what's my vector equation of line number 2? This is the vector equation for line number 2, right? Therefore, in the position vector of OD, right, I'm going to equate it as the, or represent it by using the vector equation of the line number 2. Okay, so from here, they are saying that AB equals to BD. This one actually means that the length of AB equals to the length of BD. Alright, so before I can find out the length of AB, maybe I need to find out the vector of AB first. How to find the vector of AB? So it should be AO plus OB. So refer back to your part A. What is your AO? So AO will be 2, negative 1, and negative 4. So refer back, yeah. So you are having 2, negative 1, negative 4. plus OB. So your OB is 520. All the position vector is given in the part A. Okay. So for my AB, I'm having 7, 1, and -4. Then how about for BD? Okay, so for the vector BD, because before I can find the length for BD, I need to know what's the vector of BD first. So to find the vector of BD, I'm using BO plus OD. So BO is -5, -2, and 0 plus OD. So OD is the vector equation I showed you just now, -2 plus 3 mu and so on. Okay, so simplify them. Okay, so this is what we get. All right. Okay. Then now we are trying to use this information provided in the question to start and get the position vector of D. So they say the length of AB equals to the length of BD. That means the modulus of AB equals to the modulus of BD. So modulus of AB is what? So this one basically means the length, yeah? Okay, so the modulus of AB is this one. 7 square, A square plus B square plus C square, square root. Then the modulus of BD will be, so -7 plus 3 mu square, and so on, yeah? X square plus Y square plus Z square. Okay, so for the left-hand side, for both sides, the square root, I will just cancel them off. All right, and then left-hand side, if you expand everything, you'll be having 66. Okay, so for this part, no other choice. You have to expand the quadratic, all the equation, all the expression terms slowly. Okay, so I'm having 49, then minus 42 mu, then plus 9 mu square. Okay, then for the second bracket here, I'm having 1 minus 2 mu, then plus mu square. Then this part, you're having 16 minus 16 mu, then plus 4 mu square. Okay, then again, you can try to have a look, see whether you can simplify all the term or not. Let us have a look, yeah. If you simplify everything very carefully, right, by right, you can see that 66 can be cancelled off with all the constant term on the right, because the total constant term is also equal to 66 on the right. Then you try to simplify all the term with mu square. So if you have a look for all the mu square here, you're having 9 mu square plus 1 plus 4, which is 14. So you're having 14 mu square. Then for the mu here, -42, -2, where else, yeah? -16. So by right, you should be having -60 mu equals to 0. Okay, then after that, I'm having 2 mu. I factorize out something that I can factorize. So minus 30 equals to 0. Okay. Then now I'm having to answer for the mu here. So mu equals to 0 and also mu equals to 30 over 7. Okay, so for these two values here, we will actually ignore the value of mu equals to 0. Okay, so why do we need to ignore the value of mu equals to 0? If you have a look for my vector BD, right? If you let mu equals to 0, okay, then basically you can observe that AB is equals to DB. So by right, AB and DB should be two different vectors, right? But if you let mu equals to 0 here, you substitute inside, then AB, this is AB equals to DB. Okay, so which is not logic lah. Therefore, we ignore the value of mu equals to 0. Therefore, if you want to get the position vector of OD, you have to use this particular value, 30 over 7. So substitute 30 over 7 into the position vector of D equation. okay, the column vector, right? So what do you get for your OD here? If you didn't do any careless mistake, by right your OD should be 76 over 7i, then 37 over 7j, and minus 32 over 7k. Okay, so basically this is how we get the position vector of OD lah. Alright, so maybe the trickier part is this one, where you need to double check why do you need to ignore the answer. So again, the reason is because of, if you substitute mu equals to 0, then basically AB is equals to the vector of DB. Alright, so which is no logic. It should be two different vector. Okay, so this is how we solve question number 8. Okay, so we are now at question number 9. Alright, so we are having Z and W defined by all these, okay, they are both complex number. So express ZW in the form of A plus BI, and then your answer should be in the exact third form. Okay, so it is a multiplication of two complex number, so we just multiply them together. Okay, so just like how we expand the bracket, yeah. So first term multiply with first term, first term multiply with second term. So from here you're having -3, then plus 3 square root 3i. Then after that, I'm having second term multiply with first term, second term multiply with second term. So if you simplify this one, you're having a plus 3i, and then -3 square root 3i squared. So please take note about the I square here. I square, you should know that it is equals to -1. Okay, so the I square basically is equals to -1. So when you're having negative I multiplied with 3 square root 3i, you're having -3 square root 3i squared. So if we change I square become -1, then you are having positive, you'll be having positive 3 square root 3. Okay, so I group all the term without the I together. So I'm having 3 square root 3 minus 3, which is the real part of the complex number. And then the imaginary part of the complex number will be 3 square root 3 plus 3. And then I factorize out the I. Alright, so this is basically the multiplication of two complex number. Alright, so just need to be extra careful with this one when you're having the term of I square. So please make sure that you change it become -1. Okay, so let's have a look for part B. So for part B, they want us to express Z and W in the form of exponential form. And then this is the range of the R and also the theta. Give again the exact values of R and theta in each case. So we need to have the exact value here. Okay, so before we continue also, let's have a look for the R. Basically the R here means the modulus of the complex number. Okay, and then the theta here will be the argument of the complex number itself. Okay, so that means we need to find the modulus argument for the respective complex number. Then we just rewrite into the exponential form. Okay, all right, so let's start. Okay, so let's have a look for Z first. So my Z here is 1 minus I. Okay, so what's the modulus of Z? Okay, so for information, R is the modulus, yeah? Okay, so R is the modulus of Z. So Z will be, you are taking 1 square plus B squared. 1 square is the real part plus the coefficient of the imaginary part, which is -1, and then you square it. So without the I, yeah? Okay? Right, so for this part, if you simplify, you're having square root 2. This is the modulus of Z. Then to get the argument of Z, okay, so you need to have a look for the quadrant. In which quadrant your complex number is located. Okay, so if it is in the first quadrant, then it will be tangent inverse B over A. Okay, so the B here means the coefficient of the imaginary part. Then the A here means the real part. Okay? All right, and then usually for this tangent B over A, right, it is the basic angle. So I will call it as theta. Just make it simple, I make it as theta. If your complex number is in the second quadrant, then the answer will be pi minus the basic angle. Then if let's say they belongs to third and fourth quadrant, right, we have to measure it in the negative angle opposite direction. So this one will be negative basic angle, then this one will be negative of pi minus the basic angle. Okay, so these are the four quadrants that we have. So if you have a look for our z, z is positive 1 minus I. Positive 1, positive x, then minus 1 means negative value y, negative y. So your z is belongs to this quadrant. Okay, so your z is in this quadrant. So to get the answer for this quadrant, it will be negative pi. So negative pi means negative basic angle, which is tangent inverse b over a. Your b, right, don't consider the sign. So you just take the original value b, which is the 1, divided by the a, which is the 1. Ignore the negative sign. Okay, so from here, I'm having negative pi over 4. So very easily, you can rewrite your z into the form of exponential form. So z equals to square root 2, then r power negative 4 pi over 4i. So this is my z. Okay, then how about the w? Okay, so simply happen for the w here. So for w, I'm having the complex number negative 3 plus square root 3i. Negative 3 plus 3 square root 3i. Okay, so first step, I try to find the modulus of w first. So this is negative 3 squared plus 3 and then square root 3 squared. Okay, so if you try to simplify this particular part here, you're having 9 plus 27. So further simplify, you're having square root 36, which is equals to 6. Okay, then how about the argument of w? Okay, so argument of w, if you have looked for this original complex number here, negative 3, then positive y. Negative 3 means the value x is negative, then the value of y is positive. Value x negative, the value y positive, so your answer, your complex number is in the second quadrant. So to get the argument in the second quadrant, we have to take pi minus the basic angle, which is tangent inverse b over a again. So your b is 3 square root 3. A is a negative 3 lah, but again, we have to ignore all the negative signs, so I just put it as a 3. So press calculator to help a little bit. Tangent inverse square root 3. Okay, so tangent inverse square root 3 will give you the answer 60 degree. So 60 degree means pi over 3. So you take pi minus pi over 3, and therefore your argument of w will be 2 pi over 3. Then again, we write your w into the exponential form, so it will be 6, then r. Also, it is not r, it should be the e. So that's part I also write out wrongly just now. So it should be e. Okay, so 6, then e power 2 pi over 3i. Okay, so this is how we find out the exponential form for z and also w separately. Yeah, so this is what we have for part number B. Okay, so let's continue to part C. Okay, so for part C, on Argand diagram, the points representing W and also ZW are A and B respectively. So prove that the triangle AOB is an isosceles triangle where O is the origin. Okay, so for this part, right, let us figure out how to sketch the triangle, the point here first, W and also ZW. Okay, so I think for W, it is negative 3 plus 3 square root 3i. Then ZW is something that we get just now, right? So 3 square root 3 minus 3, and also this one. Okay, so for me, when I want to sketch the point here, because all this third form, right, didn't show out clearly what is the value in decimal form. So I need to use calculator to find out the decimal form first. then only can sketch it. All right. Okay. So let's have a look here. Okay, so we need the calculator to help us to get the decimal form. Okay, so let's have a look for maybe W first, right? So W is negative 3 plus 3 square root 3i. What's the value for 3 square root 3? So 3 square root 3, the value is basically around 5.20. Okay, so it is something like your point A, point A is W, right? So your point A, right, the coordinate is more or less like negative 3 with 5.20, which is the W lah, okay? Then how about the ZW? So for the ZW, this is what we calculate just now. So if you try to get the calculator and get the decimal number, yeah? So 3 sub 3 minus 3. Sorry, minus 3 outside. Okay, so it is more or less 2.20, 2.2. If you want to make it in this way, so that we roughly know where to sketch. So it is 2.2. Then how about the y coordinate? So the y coordinate, I think it's around 8.2. Okay, so one is 2.2, then another one is 8.2. Okay, so 2.2 and 8.2 for the point B, which is that W. Okay, so all this will not be given any extra marks. It is just to help us to sketch the diagram in an easier way. Okay, so from here, I try to label all the value. They want us to have these 2 points here. So maybe I need to have my mean value. I'm having negative 3 also. Okay, so maybe I put it in this way. Okay, so maybe I try to label all the point here. I'm having negative 1, negative 2, negative 3. Then this is 1, 2, and 3. Then for the y-axis also the same. Try to use the same scale for the x and y-axis. Okay, all right. Then I want to have it until, oh, that is enough, I think. Okay, so let us start, yeah? So my point A is negative 3 and 5.2. So negative 3 and 5.2, you roughly draw. Okay, so this is basically my point A, right? But yeah, so W is point A. So ZW is point B. Yeah, so this is my point A, which is W. And then how about for the point B? So point B is 2.2 and then 8.2. So it'll be roughly here. This is my point B, which is ZW. Okay? And then they want us to prove that the OAB is an isosceles right angle triangle. O is basically the origin. So the triangle that we have here basically is something like this. Okay? Yeah, so this is what we have. So this is my triangle. And they want us to prove that this particular triangle is a right angle triangle and isosceles. So there are two important things that we need to prove. The first one is isosceles. The other one is right angle triangle. Okay. So isosceles means that there are two sides of the two sides of the length for the triangle are equal. Okay. Or maybe what you can prove it isosceles is you can prove that there are two angles in the triangle is the same, where the other one is actually different. Okay. So let's have a look. How can we prove it? So before we prove it, maybe I want to have a look for the point OA first. The length for the point OA is already known just now because it is actually the length for the complex number W. So just now, complex number W, I already know the length is 6. So I want to put it here so that I can make it as a reference for my calculation later. So OA is 6, this length. Okay, all right. So now let's start here. First of all, maybe what I want to find out is the angle first. So if I want to find the angle, I'm interested to find the angle of AOB. So how can I find the angle of AOB? So if you have a look for angle AOB is this one, right? So to find the AOB, the angle inside this triangle, I will use this large angle here minus the small angle. So the blue color angle minus the green color angle, then you'll get the angle AOB. So what's the blue color angle here? If you have a look for this complex number, right? So the blue color angle basically is the argument of W. So basically we are using argument of W minus the green color angle. So what's the green color angle here? So you can see that it is basically the argument of the complex number ZW. Okay, so minus the argument of complex number ZW. Okay, all right, so this is basically how we can find out the angle AOB lah. Because if I know what is the angle for this one, then maybe later it will be easier for us to prove that this is a right angle and also isosceles triangle. Okay, right, so let's continue. Okay, so for argument W, no problem lah. And then for your information, argument of ZW, right, can be written as argument Z plus argument of W. So we learned some shortcut formula before, right? When you multiply two complex numbers together to get the argument, you can have a shortcut where you just take the two arguments separately and add them together. Okay, so this is what we have lah. So instead of getting the argument of ZW, you can actually find them by using argument Z plus argument W. So from here, argument W and argument W can be simplified, right? After you minus them, therefore you're having negative argument Z. Okay, so what is the negative argument Z? Argument Z, we also get the argument, the angle of the Z just now, right? The argument of Z just now, which is negative pi over 4. So substitute negative pi over 4, your answer from part B, and therefore you have pi over 4 here. Okay, so that means now I successfully get, now I successfully get the angle here, which is pi over 4. Let me write it out first. So this angle, it is actually pi over 4. Okay, then next step. Next step, if I want to prove that this is 90 degree or this is pi over 4, I feel like it is not as easy. Okay, so what I want to do now is maybe I try to find out the length of AB. And if I can prove that the length of AB is equals to 6, then basically the result is out because these two sides are the same, which means that these two angles should be the same. And this must be 90 degree at last. Okay, all right, so now I will find out the length for AB. Okay, so again, just to write out the A again, what's the coordinate for the A? So the coordinate for the A means the W, right? So again, just now we are having the W here. So W is negative 3 plus 3 square root 3i. Negative 3 plus 3 square root 3i, sorry. So it will be x equals negative 3. Then the y is 3 square root 3. Then for the B basically is ZW. So our coordinate just now is here. 3 square root 3 minus 3, 3 square root 3 plus 3. Okay, so how can I get the AB? So to get the length of AB, you are taking x minus x, x1 minus x2. Okay, so maybe I take b minus a lah. So this is the b. x1 minus x2. Then you square it. Then y1 minus y2. And you square it. Okay, so you will realize that you're having 3 third 3 square, which is 27. Okay, then this part is 3 square, which is a 9. So equals to square root 36, which is equals to 6 as well. So now I can see that this length of AB is equals to 6. Okay, alright. So now we are getting closer and closer to the conclusion. Okay, so I can start making some simple conclusion now. Okay, so since AB is equals to OA, right, the length, both of them are equals to 6. Okay, so that means the angle AOB should be equals to the angle ABO, which is equals to pi over 4. So that means this is equals to pi over 4. Okay, and hence the total triangle angle should be 180, right, which is the pi. So therefore, the angle of BAO is equals to pi minus pi over 4 minus pi over 4 again. So you're having pi over 2, which is a right angle. Okay, so from here you can see that you're having two sides equal length with the 90-degree here. So basically the AOB, the triangle, AOB or OAB is an isosceles right angle triangle. Okay, so although this one is only given 2 marks, I believe that they might have some other different ways. Okay, so to get the answer in the shorter form. Okay, but for me, I feel that this is one of the techniques they can try to consider. Okay, so by finding out one of the angle and also by trying to find out also one of the length of the side, then you see that, okay, these two lengths are the same. And also it concludes that these two angles should be the same as well. And finally, you can prove that this is 90 degrees. Okay, so this is how we solve the part C for this question. Then let's have a look for part number D. Okay, so using your answer in part B, right, prove that tangent 5 pi over 12 is equals to this one. Okay, so they have hint us very clearly that where you need to use answer in part B. Okay, prove that 5 pi over 12, tangent 5 pi over 12 equals to this number. So let's have a look. How can we get 5 pi over 12 first from part B? Or maybe you can observe what can we get from part B first. Okay, so for part B, right, I'm having the modulus of Z and the modulus of W. But part D is not related to modulus. They are talking about when you see tangent, basically it is talking about the argument. So let's have a look for the argument of Z and also the argument of W. Okay, so if you try to observe these two values here, if you take 2 pi over 3, which is the argument of W, plus the argument of Z, maybe you can try error and have a look out. See whether you can get 5 pi over 12 or not. So basically you can see that it is 5 pi over 12. Right? So that's why they already hint out very, very clearly where you have to use your result in part B. Therefore, you come back to part B and have a look for all the respective results here. Okay, so basically we can use the argument for Z and also argument of W. So you can see here, yeah, 5 pi over 12 is equals to these two arguments adding together. Okay, all right, so remember this, yeah? So let's come back here. So from here, I know that 5 pi over 12 is equals to 2 pi over 3. Okay, then plus negative pi over 4. And again, what is 2 pi over 3 just now again? So 2 pi over 3 is the argument of W. Then the negative pi over 4 is basically argument of Z. When you add the argument together, right? So like what I told you just now, we have a shortcut. formula where the argument of wz is equals to argument of z plus argument of w. So we are applying this here. Okay, so I combine them together, become argument of wz or argument of zw also can. Okay, then you ask yourself how to find the argument of wz. Yeah. So in part A, we have actually successfully found out the zw or wz just now, which is this one. So how can I find out the answer for this part? So like what I told you just now, this value is approximately 2.2. Then this one is approximately 8.2. So it is in the first quadrant. To get the argument for zw, in the first quadrant, it is tangent inverse value of b divided by value of a, right? Okay, so we go back here. Therefore, argument of wz can be written as tangent inverse the value of b, which is 3 sub 3 plus 3, divided by the value of a, which is 3 sub 3 minus 3. Okay, and this is basically equals to 5 pi over 12. So I think the answer is quite obvious now. If you bring the tangent inverse over, so you'll be having tangent 5 pi over 12 equals to this 3 sub 3 plus 3, then divided by 3 sub 3 minus 3. All right. And then if you try to have a look and then you realize that, oh, again, something different here. Okay, so you have to actually further simplify it. If you take out the 3, then this is only the correct answer that they want us to show. Okay, so you have to further simplify it first. All right. Okay, so this is basically how we solve this question number. Okay, so the last question for this paper. By writing secant power 3 as 1 over cos power 3, they want us to show that dyd theta equals to this equation. Okay, so I'm having this, yeah? So y equals to 1 over cos power 3. Okay, so this is a fraction. When I want to differentiate maybe a fraction or a quotient like this, right? A fraction like this, we have to use the quotient rule. Okay, so you can refer to the formula booklet for the quotient rule, right? Okay, so if you having y equals to u over v, which is in the fraction form, then basically the dy dx is using the quotient rule, and the formula looks something like this, where you have to square the denominator, copy the denominator, differentiate the top part first. After that, minus, copy the top part, differentiate the denominator. So this is basically the general formula for quotient rule. Okay, all right, so let's have a look for our dy dx here. Okay, so v squared. So v squared means I have to square the cos power 3. So it will become cos power 6. You square the cos, right? Okay, so copy the cos power 3 theta. Differentiate the thing on top. Differentiate a 1, you get 0. Then minus, now you copy the 1, you differentiate the cos power 3 theta. Okay, so how to differentiate cos power 3 theta? It can be written as cos theta power 3, right? So according to what we learned previously, you have to pull the power in front. So pull the power in front means you're having a 3. And after that, copy the bracket, power minus 1 become a 2. Okay, and then not completed yet because you have to differentiate the thing inside the bracket, inside the inner part. So differentiate differentiate cos theta, you'll be having sine theta. Differentiate cos, you have negative sine. So negative sine theta. Okay, so this is how we apply the quotient rule here. And of course, before we can get this answer, we have to simplify it first, so that eventually we express our answer in this pattern. Okay, so 0 multiplied with anything is still 0. So for this part, if I multiply them, I'm having 3. Positive 3 sine theta and then cos square theta divided by cos power 6 theta here. Then this can be cancelled off and this will become a 4. Then 3 sine theta over cos power 4. 1 over cos power 4 can be written as secant, right? So you're having secant power 4 theta. So this is how we get the answer that it wants to prove. Okay, so this is all you have for part A. Then let's continue to part B. For part B, they say that variable x and theta satisfy this differential equation. And they are given us some initial value here. Then solve the differential equation and find the value of cos theta when x equals to 0. Give your answer correct to 3 significant figures. Okay, so first step, we have to solve the differential equation first. Okay, so copy the differential equation that we have. Okay, so first step, we have to separate the variable first. That means all the data at one side, all the x at one side. So for this one, I will want to group all my data on the left. So cos power 4 theta, I have to bring it over here. If I bring it over here, I will be having sine theta divided by cos power 4. So I make it become sine theta multiplied with secant power 4. 1 over cos means secant, right? Okay, so I'm having secant power 4 here with d theta. For x plus 3, I just keep it, remain it on the right. So bring this x squared plus 9 over. I will be having x plus 3 divided by x squared plus 9. Then for the x here, dx here, I bring it up. Alright, so from here, you can see very clearly that I have successfully separated the variable, all the data at one side, all the x at the other side. Okay, so after I separate the variable, I just put the integration sign. Okay, then now I have to integrate this particular part on the left. If I want to integrate this one, you will see that this pattern appears somewhere else just now, right? Which is this one. So that means, excuse me, if you differentiate secant power 3, you will get this. Therefore, if I do it the other way around, that means if I integrate this one, I will get back the secant power 3. But for the answer here, I'm having a 3 in front of this sine and secant. So for correct integration, what I need to do is I have to multiply a 3 here. But to make the equation balance, also I have to divide by a 3. Okay, so integrate this whole thing by using the result just now that it asked us to prove. So integrate this whole thing, I'm getting 1 over cos power 3. Or secant power 3 also can. Right, so for this part, I just remain and copy the 1 over 3. Then integrate this whole thing, I'm having secant power 3 theta. Okay, so left hand part done already. Let us have a look for the right hand side. Okay, so for the right hand side here, I want to separate it, become 2 fraction where it is x divided by x squared plus 9 and also 3 plus x squared plus 9. Then only I try to observe what's the pattern that I have here for these two terms. Okay, so for this one, x over x squared plus 9, it is basically the f prime x over fx pattern. Okay, so how I know that it is f prime x over fx pattern? Because I know that if I differentiate x squared plus 9, I will get 2x. So the 2x, I already have the x on top. Therefore, for this particular integration, I also can make it as, I can make some small adjustment here, where I want to multiply a 2. In this integration, And outside, to make it balanced, I want to divide it by a 2 as well, so that this expression is still the same one like original. Okay, I realized another mistake here. This is x. Okay, alright. Then for this term, okay, so for this particular term, I will want to take out the 3 first. Then integrate 1 over x squared plus 3 squared. Okay, so why I want to replace it become 1 over x squared plus 3 squared? Because in our formula as well, there's one formula where if you want to integrate 1 over x squared plus a squared, you will be getting 1 over a and then tangent inverse x over a. Okay, Alright, so where in this case here, our a is a 3 lah. Alright, so maybe you ask how I know that I have to use all this rule here. You have to be very familiar what kind of integration is included in the syllabus. So by observing the relative pattern, right, the related pattern, then you should know roughly which is the correct formula to be used here. Okay, alright, so I have settled everything here, then I start to integrate this part. So to integrate this part, I'm using this result, right? So my fx is basically x squared plus 9. So ln fx means I'm having half, and then ln x squared plus 9. Okay, then for this part, copy the constant 3, integrate 1 over x squared plus 3 squared. Your 3 is the a, yeah? So this is the result that you have. So you should have 1 over 3 tangent inverse x over 3. Should be a plus c at the back after you complete the whole integration. Okay, so rephrase my answer a little bit. And 1 over 3 can be simplified, and therefore you're having tangent inverse x over 3 then plus c. Okay, so now before I can answer the question to find the value for cos theta, I need to find out the value of c first, the constant value first. Okay, alright, so I'm using the initial value given here in the question. So when x equals to 3, you are having theta equals to pi over 3. So now you try to substitute all the value inside. Okay, so 1 over 3 secant theta power 3. So I'm having secant theta, which is pi over 3, then power 3 here, equals to half. Then ln 3 squared is a 9. So 9 plus 9, you get 18. Okay, and then tangent inverse x over 3. So again, x is 3. So 3 divided by 3, you get a tangent inverse 1. Then plus c. Okay, alright. So what's the value for secant pi over 3? When you're having cos pi over 3, right? Cos pi over 3 means cos 60 degrees, it is a half. So 1 over half, excuse me. So 1 over half means 2. So 2 power 3 means 8. Okay, so this one I don't touch it yet. Tangent inverse 1, you will be getting pi over 4, then plus c. So from here, you will get a c value which is in a long decimal number. So to make it most accurate, right, I will try to copy out the whole series of the number. And this is the value of the c that you should have. Okay, then after that, only we go back to our final part of the question. They want us to find the value of cos theta when x is equals to 0. So let us substitute it into my final answer here. So maybe I write out in this part. Okay, so when excuse me, when x equals to 0, okay, so I'm having 1 over 3 cos power 3 theta. I don't know the theta, right? Then after that, I'm having ln, half ln, 0 plus 9, I get a 9. Okay, then tangent inverse 0 over 3 means tangent inverse 0 lah. Tangent inverse 0, you also get a 0. Then plus c. So c is this long value here. Okay. Then what do I have for cos power 3 data? I take all this whole value here back, go down to the denominator. So if I simplify it, I will be having 0.217198435. Then of course, I need to take cube root to get the value of cos theta. So I take cube root. Okay, when I press calculator, by right, I'll be having 0.60110766161. And rephrase it correct to 3 significant figure answer, it should be 0.601. Okay? Yeah, so this is how we get the value for cos theta. So for this whole part here, you can fully use the calculator to help you. But again, a reminder to you, when you want to use the calculator to get the value, please make sure that you keep your calculator in the radial mode. Okay, because we are getting, especially this part, you have to put it in the radial mode, okay, because you are having the trigo with some value here, all right, which is the in the unit of radian. It will be easier if you put your calculator in the radial mode here. All right, yeah, so this is how we solve all the questions for this video. So thank you very much for watching.